Welcome to section 1.4. These are the examples for this particular section. So I'm going to start off with number 9. So we have the square root of 2t minus 1 is equal to 1. And so what we want to do when we get a radical is we simply want to get rid of that radical. And so the way that we're going to get rid of it is by raising both sides to the second power. And so what's going to happen is that the square root of 2t minus 1 raised to the second power simply becomes 2t minus 1. So if I have the square root of x and I raise that to the second power, I just get x. And so, of course, 1 to the second power is simply 1. And then at this point in time, we're going to add 1 to both sides. So we get 2t is equal to 2. And then divide both sides by 2, and we get that t is equal to 1. Whenever we deal with radicals and equations, we need to check them always. And so here we're going to have 2 times 1 minus 1 is equal to 1. So the square root of 2 minus 1. 2 minus 1 is 1, and we can see that this checks out. And so, And so the solution is, in fact, that t is equal to 1. And so now we're looking at number 15. And so 15, we have the fifth root of x squared plus 2x is equal to negative 1. Same thing that we did in the previous example. We're going to raise both sides to the fifth power. So whatever that index is, that's what we're going to use. And that's going to cancel out our radical. We're going to have x squared plus 2x is equal to negative 1. Since we have a quadratic, we're going to move the negative 1 over to the left side, which means we're just going to add 1 to both sides. We get x squared plus 2x plus 1 is equal to 0. We're going to go ahead and factor this. And so, like we did previously, that's just going to be x, and then 1 is easy because it's just 1 and 1, right? And so we're limited here in the different combinations, which is kind of nice. And so that's going to be x plus 1 and x plus 1 is equal to 0. In other words, we get x plus 1 to the second power. Since it's a double root, we're just going to use one of them. And so x is equal to negative 1. Once we do that, we have to check it. And so we have the fifth root of negative 1 to the second power plus 2 times negative 1 is equal to negative 1. Negative 1 to the second power is just 1. 2 times negative 1 is negative 2. So we have the fifth root of negative 1, and we get that the answer is, in fact, x is equal to negative 1. The next one that we're going to do is number 25. And so in this particular problem, what we're going to do is we want to subtract the 3 from both sides, right? We want to leave the radical by itself. And so we get x minus 3. And then just like we did previously, we're going to go ahead and square both of them. The radical here on the left side is going to cancel out, so we're left with 3x plus 1. Here on the right, we're going to end up with x squared minus 6x plus 9. And just to, real quick, so everybody can see how we got that. So x times x is x squared. We're going to FOIL it, right? And so x times negative 3 is negative 3x. And the same thing here in the middle. And then plus 9. And that's how we got the x squared minus 6x plus 9. Move everything over to the right side. So I'm going to subtract 1 and subtract 3x. So we get x squared minus 9x. 6x minus 3x is 9x. And 9 minus 1 is a positive 8. And so we're going to go ahead and factor this. And so, again, x squared is just x and x, right? 8. We have two different possibilities. We have 1 and 8 and 2 and 4. But since a middle term is negative 9, the 1 and 8 are the ones that make sense. Since that's a positive, then they're both going to be negative. Negative and a positive. And so we're going to set each one equal to 0 to see. And we get x is equal to 1 and x is equal to 8. And so now what we're going to do is we're going to check to make sure it works, or make sure that it is a solution. So we're going to use the 1 first. And so 3 times 1 is 1. 3 times 1 is 3, and 3 plus 1 is 4. And we get that the square root of 4 is 2, and you can clearly see that this does not work, right? So this is not a solution. So the next one we're going to go ahead and check. We're going to do the 8. And so it's 3 plus the square root of 3 times 8 plus 1 is equal to 8. And that's going to be 24, right? So 24 plus 1. I'll go ahead and do that in the next line. So it's going to be the square root of 25 is equal to 8. Square root of 25 is 5. And then we can clearly see that this is the solution. So it looks like the solution is x is equal to 8. The next one that we're going to do is number 31. And so you always want to check all of these answers to make sure there's no answers that are extraneous. And so in this case, x is equal to 1 is an extraneous answer, or solution, and doesn't work. And so for number 31, you notice we have two radicals. There's several ways that you can do this. What I tend to try to do is get rid of the minus. So what I'm going to do is I'm going to move or add the square root of x minus 1 to both sides. Now what we're going to do is we're going to go ahead and square both sides. And what happens when you have something like this is that you are going to end up with another radical, so you're going to have to square it a second time. And so we get 3x plus 1. And then on this side here, when I square this, I end up with 4 plus 4 square root of x minus 1 plus x minus 1. And so if you were to do 2 plus square root of x minus 1 times 2 plus square root of x minus 1, you would get this right here. So we can go ahead and combine like terms on this side here. So 4 minus 1 is 3. So I got 3 plus x plus 4 square root of x minus 1. And then here I get 3x plus 1. So what I want to do here is I want to move the 3 and the x over to the left side. So if I do 3x minus x, I get 2x. And then 1 minus 3 is negative 2. And so I get 2x minus 2 is equal to 4 square roots of x minus 1. And we're going to go ahead and square both sides again to get rid of the radical. And so 2x minus 2 squared, what it's going to give us is 4x squared minus 8x plus 4. And then on the right side, we'll end up with 16 times x minus 1. And so now we're going to go ahead and combine like terms as much as possible. Actually, let's go ahead and distribute that 16. And so now what we're going to do is, again, just combine like terms, right? And so we get here, we get 4x squared. Now, negative 8x minus 16x is negative 24x. And then 4 plus 16 is 20. And so what happens at this point in time is that we can actually take out a 4. When we take out a 4, we end up with x squared minus 6x plus 5 is equal to 0. So let me go up here so I can rewrite this. And then we're going to go ahead and just factor out the x squared minus 6x plus 5. And when we do that, we end up with x minus 1, x minus 5 is equal to 0. And so our solutions are either going to be x is equal to 1 or x is equal to 5, right? And so we're going to go ahead and check both of them. And so let me go ahead and put that right here. So I'm going to go ahead and check the 1. So 3 times 1 plus 1 minus 1 is equal to 2. And so 3 times 1 is 3 plus 1 is 4, right? And that's just going to be 0. And we can see that this is in fact going to check out, right? So that's the first one. And so the next one is going to be the 5. So 3 times 5 plus 1 is minus 5 minus 1 is equal to 2. So that's going to be 3 times 5 is 15 plus 1 is 16. So we got the square root of 16 minus square root of 5 minus 1, which is going to be 4. And so this is going to be 4 minus 2, and you can clearly see that that's going to work. And so our solutions for this problem is 1 and 5. X is equal to 1 and x is equal to 5. All right, let's look at number 44 now. And so number 44, we have x to the fourth minus 10x squared plus 25. And so what we're going to do here is we're going to go ahead and factor this. There's several ways of us doing this. And one of the ways that I tend to like to do it is using substitution. So what I'm going to do is I'm going to say u is equal to x squared. Now, this looks like a quadratic, but it's not a quadratic. So, however, this exponent is twice of this one, similar to a quadratic. And so, hold on a second. I don't want. Let me get to my eraser here. I don't want it to be. So u is equal to x squared, and then u squared is equal to x to the fourth. And so if I were to rewrite this, I would rewrite this as u squared minus 10u plus 25 is equal to 0. Which is going to give me, since that's a perfect square and that's a perfect square, and the square root of that is u, right? The square root of 25 is 5, and if I do that times 2, I get 10u, which is what I have in the middle. So since this is a perfect trinomial, I know that I can end up just factoring this as u minus 5 times u minus 5 is equal to 0. It's a double root, right? And so we're just going to go ahead and do the u is equal to 5. Now, at the beginning, we said that u is equal to x squared. So we're going to replace the u with x squared. So x squared is equal to 5. And then we're going to go ahead and do the square root of both sides. So then x is actually equal to plus or minus the square root of 5. And so our solution would be negative square root of 5 and the square root of 5. Number 50 is similar to what we just finished doing. Again, we're going to go ahead and do substitution. So u is going to be equal to 2x plus 5. And so if I rewrite it, I'm going to have u squared minus u minus 6 is equal to 0. So it looks a whole lot better to solve this. And if I factor this, I'm going to end up with the following. And I'm going to have u minus 3 times u minus 2. So my two possibilities are u minus 3 is equal to 0 and u minus 2 is equal to 0, which means that u is equal to 3 and u is equal to 2. And so I'm going to go ahead and check it. Well, actually, now I got to go back and replace the u with the 2x plus 5. So 2x plus 5 is equal to 3, and then 2x plus 5 is equal to 2. So I'm going to go subtract 5 from both sides. So 3 minus 5 is negative 2, so x is equal to negative 1. And then over here, I'm going to subtract 5 from both sides. And so I get that, oops, sorry. That should have been a plus, minus 2. My apologies there. And so I'm going to have negative 7, so x is equal to negative 7 over 2. Sorry about that. That should have been u minus 3 times u plus 2. My fault. And so in fact, they both are solutions. So my solution set is negative 1 and negative 7 over 2. And the last one I believe that we're going to do is 64. I don't think I have another one after that, but we'll double check it here. All right. Yep, that's the last one. Okay. So in this one again, what we're going to do is we're going to raise both sides to the fourth power to get rid of the radical. So we end up with 4 minus 5x squared is equal to x to the fourth power. And then so what we can do is move everything to one side. So it's going to be x to the fourth plus 5x squared minus 4 is equal to 0. And so if I do substitution, if I allow u to be x squared, then I can rewrite this as u squared plus 5u minus 4. And so remember, since u is equal to x squared, then u squared is equal to x to the fourth power. And so this one over here doesn't have, you can't factor this one the way it is. So what we're going to do then, is we're going to go ahead and use the quadratic equation. And so what's going to happen here is that we're going to say, okay, so here what we have is the following. We have that u is equal to, using this information here, -5 plus or minus, right? -5 squared minus 4 times 1 times -4, all over 2 times 1. So we're going to just do this for a little bit, and then we're going to replace it with the x squared to kind of make life a little easier. So this is going to be -5 plus or minus 25 plus 16 over 2. And so what I'm going to have here is -5 plus or minus the square root of 41 over 2. And so now what I'm going to do is I'm going to replace this with x squared. So it means that x squared is equal to plus or minus. Well, sorry, let me go back here. Let me erase this real quick. All right, let me go back. So x squared is equal to -5 plus or minus the square root of 41 over 2. But x is equal to plus or minus the square root of -5 plus or minus the square root of 41 over 2. And so what happens is here is that I have to test both of them out. Now, since I have the square root, if I were to do the first one, x is equal to minus square root of -5 minus square root of 41, we can see that actually plus or minus, regardless of what I do, this one is going to be a non-real, right? This is going to be a complex solution. So the -5 minus square root of 41 over 2 is not real. And so therefore, if I were to find the roots, the only possible solution that we have to this particular problem, ignoring the minus, so both of these are going to be non-real. Now, if I were to use the x is equal to negative square root of -5 plus square root of 41 over 2, that's also not real. And so what's going to happen then is that the only solution that I have to this entire one is simply x is equal to the positive square root of -5 plus square root of 41 over 2. And so that becomes my solution here. And that's the end of 1.4. Thank you.